Hello everyone, this is Srikanth working as assistant professor in electrical department. Now I want to discuss about impedance, admittance as well as power in AC circuits. Before moving to impedance and admittance, I want to discuss about small formulas, that is rectangular to polar, polar to rectangular. How will convert the rectangle polar, polar to rectangular. For this, here I have a small triangular. Just observe this triangular. From this triangle, can you write the R value? So this is X value we have, Y value we have. Can you write the R value? Yes, we can write the R value. R equal to root of X square plus Y square. Can you write the X and Y values? Yes, we can write the X and Y values. X is nothing but R cos theta. Y is nothing but R sin theta. Same as angle also. For angle, you can write tan inverse X by Y. So R equal to X square plus Y square, and X equal to R cos theta, Y equal to R sin theta, as well as theta equal to tan inverse X by Y. This is about intermediate formulas. So same logic. So I'm using in rectangle to polar, polar to rectangle form. So this is my rectangular form, and this is my polar form, and this is my trigonometry form, and this is my exponential form. Now for rectangular form, just observe, this is your impedance and this is your X plus or minus jy. This is imaginary value and X is your real value. From the triangular, if you know the X plus Y, so you know the X value as well as Y value, you can find out the R value and you can find out the theta value. So this is your rectangular form or complex form. You can convert into polar form also. So if you know the X plus X and Y values, you can convert it to R value, R with angle value. That is your polar form. So if you have the rectangular form, you can convert it to polar form. Here I want to find out the R value. What is the R value? R equal to root of X square plus Y square. What is the theta value? Theta value is tan inverse Y by X. Just substitute this X and Y value, will get like R and theta values. If suppose I have the R and theta value, no, I have the polar form, we can convert it to rectangular form using the same. So I want the X value now. What is the X value? When you have the R and theta value, your X value is R cos theta, and Y value R sin theta. Just substitute those R and theta values, you will get like X and Y values. So if we have the rectangular form, we can convert to polar form, as well as if you have the polar form, you can convert to rectangular form. Okay, and trigonometry form is same as we have like a R. Here X is R cos theta, R sin theta. If suppose R is common means we will get like cos theta plus or minus j sin theta. From rectangular form we will get the formula for trigonometrical form. Same as the exponential, that is R and your angle formula. Okay, this is about rectangular to polar, polar to rectangular. Next, using these equations, we'll get like R rectangular to polar, polar to rectangular. So moving to one more topic, that is J notation. So J notation, why you require the J notation means, for every angle we have some imaginary values. For every real values, we have some imaginary values. So here I have 0 to 360, I have 0, 90, 180 and 270. For this, suppose my phase angle is, this is my phase angle. Already we discussed in last videos about phase angles. So this is my phase angle, some theta. So which is the real value and which is the imaginary value. So I will get the plus imaginary value or minus imaginary value. If you get the real plus or minus. So in this position, we'll get the plus real value and plus imaginary value. And coming to this point, minus real value plus imaginary value. Coming to in this position, minus real value minus imaginary value. Coming to in this position, plus real value minus imaginary value. So these are conditions in this different point. Just observe now. So here I have 0 or 360. So we have only plus 1. So plus 1 means if suppose convert into your polar form, we'll get like 1 angle with 0. So the angle is 0 when we have the 1 value. And so you have the real value is 1 and imaginary value is plus j. And coming to 90 degrees, your real value is 0 and imaginary value is plus j. And coming to 270, that means minus 90, your imaginary value is minus j. And coming to 180, your real value is minus 1. So here real value is plus, real value is minus 1 and imaginary value plus, imaginary value is minus j. Before going to like impedance and admittance, again we have small problems on this rectangular polar to rectangular. Now I have one problem here, that is z equal to 5 plus j10. This is my rectangular form. I want to convert into polar form. Same thing here. One more value, z equal to 10 plus j3. Again I want to convert into polar form. And same thing here, z equal to 11.18 angle with 63.43. So here I have polar value, I want to convert into rectangular form. Same thing, I have the polar value convert into rectangular form. And one more problem. So I have z1 and z2 values. So z1 and z2 values, I want to add both values. I want to subtract both values and multiplication as well as division. If you know the conversion of rectangular and polar, we will get the answer. Now, coming to first one, I have x and y values. Just substitute r equal to root of x square plus y square. Then theta equal to tan inverse y by x. Substitute the x and y value. We will get r equal to 11.18 and theta equal to angle of 63.435. So your polar value of z equal to 11.18 angle with 63.435. This is your polar value. This is your rectangular value. Just go to this also. We'll get z equal to 10.44 angle with minus 16.7. That is your polar form. This is your rectangular form. Same thing here I given to you guys. If you suppose you want to convert this, you get this value. If you want to convert this polar form to rectangular form, means you will get like this value, 10 minus j3. Okay, and coming to like one more problem, I want to add both z1 plus z2. So for this, my z value is 5 plus j10 plus, so this is your z1 value, and z2 value is 6 plus j9. Just add both, simple. 5, so real value. So real value is 11 plus imaginary values is 19. Simply will get. And subtraction also same as this. If subtract means we'll get like a minus 1 plus z1 minus z2 value. And coming to division and multiplication, just observe now, my value is 5 plus j10 into 6 plus j9. So I want to multiply both. For this, I want to convert into polar form. I want to convert both into polar form and then multiply. We know that 5 plus j10 polar form is 11.18 angle with 63.45 into and 6 plus j9 polar form value is 10.81 angle with 56.31. Okay, so this is polar form now. So it's simple now. So multiply 11.18 and 10.81. You will get 120.85. Then what about angle? So just remember, so two angles, so theta 1 into theta 2. So two angles in multiplication position. Then we need to add. So angle of theta 1 plus theta 2 is your answer. If suppose both angles are division position, so angle theta 1 by angle theta 2, then your angle is theta 1 minus theta 2. Just remember two things. So multiplication position means both need to add, division position means both need to subtract. So we'll get like how much? Add both 63.45 and 56.31. You will get 119.76. Simple. So this is about how we'll convert rectangular form to polar form and as well as polar form to rectangle. Again, before moving to impedance, we have one more concept, that is reactance. Reactance. So reactance units also ohms. So why reactance means, if suppose I have resistor and inductor connected in series. Okay, now I want to add both values. Suppose my R value is 10, L value is 5. Then how can I add? Generally, resistor units is ohms and inductor units is Henry. We can't add. So for that, I need to convert this Henrys to ohms. Same thing capacitors. Capacitor farads to ohms. For this, we have that concept is reactance. So we have inductive reactance and capacitive reactance. And we know that formula. In intermediate also we have this. So XL equal to omega L. XC equal to 1 by omega C. So XL as well XC. XL is inductive reactance and XC is in capacitive reactance. So both formulas. And here omega is nothing but 2 pi f. Omega is nothing but your 2 pi f. Okay, this is about reactance, inductive reactance as well as capacitive reactance. Now moving to like impedance. So impedance is the ratio of voltage by sinusoidal voltage by sinusoidal current. So ratio of V by I. That is your impedance in AC. In DC we have R equal to V by I. Same thing here, AC we have impedance. We have impedance. Now same, we have the units is like ohms. Impedance units also ohms. Now here I have the resistor and inductors. Both are in series now. Both are for series. So then my impedance value is R, that is your real value, plus XL is your imaginary value. So R plus J XL. XL is your inductive reactance. Same for capacitors, minus J XC. Here Y minus means reactance formula. That is for capacitive reactance is 1 by omega C. So omega C is 1 by means imaginary value is by value. So J 1 by J is will get like minus 1 by J. That is we have the answer R minus J XC. And 3 are in series. Then impedance equal to R plus J XL minus XC. Okay. From this we can convert like polar forms here. These are polar form. These are rectangular forms. This is about impedance in series. Okay. Then what about admittance? So admittance is nothing but inverse of your impedance. 1 by Z. 1 by Z. That is your admittance. So when we have the parallel circuit, so resistor and inductance both are parallel, then you need to move to the admittance. And here one more word is there, conductance. So resistor and inductor both are in parallel. Then actually this is R value and this is your L value or XL value. Then you want to convert to resistor to conductance, that is G. G is 1 by R. Then you can add. Same thing, your reactance of inductive. So inductive reactance also you need to convert into susceptance, that is 1 by XL. Then both are in parallel means we have the formula. Then admittance equal to real value, that is G, plus or minus BL, JBL. Why minus means it's a by in division position. So 1 by omega L is division position, we get like minus. Coming to capacitance, admittance equal to G plus JBC. Okay, 3 in parallel means we have the formula. Simple. This is about impedance, admittance, conductance and susceptance and reactance. Okay, now moving to power, again same logic which are using in impedance. Here also same. So we have active power as well as reactive power. We have active power, that is real power, and your reactive power, imaginary power. Same logic in power also. Okay, so now we have 3 words, that is apparent power, active power and reactive power. So apparent power is nothing but your complex power, that is mod of your apparent power, and active power. So which power you are utilizing, that is your active power, and which power not utilizing, that is your reactive power. So you have 3 powers. Now that formula is, so complex power is VI cos pi. So VI angle of your theta or pi. So now your VI nothing but your R angle of theta, same as we have discussed before. So I require now trigonometry form. Trigonometry form means that is VI cos pi plus J VI sin pi. Simple. Same as R cos theta plus R sin theta. J R sin theta. Same value that is. So you can get from this P plus JQ. So P plus JQ. So P is your real value, that means active power, and Q is your reactive power. Okay, you can see here active power and reactive power formulas. Now coming to units, the active power units is watts. So W, the kilo means kilowatts, and coming to like a reactive power, voltage, ampere and reactive. Voltage, ampere and reactive, that is your reactive power units. Kilo means kilovolts, ampere, reactive, that is your units of reactive power. And active power is VI cos pi, reactive power is VI sin pi. Now for same power we have the power triangle. So apparent power and active power and reactive power, and your angle is depending upon the impedance angle. Which angle you have for impedance? Same angle we have here. Okay, and one more thing is power factor. Already we discussed about power factor in last video. That is unity power factor, leading power factor and lagging power factor. So unity for resistance, lagging for inductance and leading for capacitance. So for power factor formula is cos phi. From this triangle, cos pi is active power by apparent power. From this triangle, cos pi equal to active power by apparent power, that is P by S. Okay, this is about power and impedance and admittance in AC circuits. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.